You know the shirt you're wearing right now? Have you ever really thought about the incredible journey it took from just a single thread into the fabric you can feel? It's this amazing story of ancient ideas and super high-tech engineering, all woven together. So let's pull back the curtain and see how it all really works. So get this, believe it or not, this simple wooden frame, a hand loom, is basically the great-great-grandfather of the modern computer. No joke. It works on a binary system, up and down, ones and zeros, to turn simple yarn into complex patterns. This humble machine really did lay the groundwork for a technological revolution that, well, it touches pretty much everything we do today. So how does this ancient computer actually work its magic? Well, it all comes down to a fundamental code that we've been using for thousands of years to, literally weave the world around us. At its heart, weaving is beautifully simple. Okay, so think of it this way. You have one set of threads stretched out nice and tight. That's called the warp. Then you take another thread, the weft, and you just go over and under those warp threads. Warp and weft, up and down. That's it. That's the basic code for almost every single piece of woven fabric in the world. And what's really incredible is that the huge variety of fabrics we see, from tough denim to shiny silk, it all comes from just a handful of these basic patterns. Think of them like the primary colors of the fabric world. The three big ones are the plain, twill, and satin weaves. Let's start with one you definitely know, the twill weave. Here the weft thread goes over one warp thread, then under two, over one, under two, and that creates this really distinct diagonal line. This isn't just for looks. That diagonal pattern is what makes the fabric incredibly strong and durable, which is exactly why it's the code behind your favorite pair of jeans. Now, on the complete other end of the spectrum, you've got the satin weave. With this one, the weft thread floats over a bunch of warp threads at a time, so there are very few interlacing points. This minimizes the texture and just lets a ton of light reflect off the surface. And the result? You get a fabric that's unbelievably smooth, shiny, and just feels luxurious. So you see, the feel of a fabric comes directly from its underlying code. For centuries, that code was all punched in by hand. But then, the Industrial Revolution hit, and suddenly there was this massive demand for more fabric, and faster. This kicked off a full-on arms race in loom technology, a quest to take this ancient craft and crank the speed up to 11. For a long, long time, this was the standard, the shuttle loom. A wooden shuttle with the weft yarn inside was literally thrown back and forth through the warp threads. Clack, clack, clack. It was revolutionary for its time, for sure, but it had a very clear speed limit. At its absolute peak, a conventional power loom could make about 200 picks, that's a pass of the weft thread, every minute. Now that sounds pretty fast, right? But in the world of mass production, it was a major bottleneck. The industry needed to go faster. The solution was to do something radical. Get rid of the shuttle completely. Enter the modern air-jet loom. Instead of chucking a heavy wooden shuttle back and forth, these machines use a powerful, precise blast of compressed air to shoot the yarn across. And the result is, well, it's just mind-blowing. We're talking up to 2,000 picks per minute. That's a tenfold increase in speed, a quantum leap in productivity that completely transformed the entire textile industry and made mass-produced clothing possible for everyone. And the air-jet isn't the only modern marvel out there. Today's looms are like a set of specialized surgical tools. You've got rapier looms that use these flexible rods to carry really delicate or fancy yarns, and then there are water jet looms that, you guessed it, use a jet of water, which is perfect for synthetic fibers that don't like getting wet. It's all about having the right tool for the right job. So far, we've been talking all about weaving, that classic grid of warp and weft. But what if I told you that some of the most important fabrics in our lives aren't actually woven at all? It sounds impossible, doesn't it? I mean, how do you make a sheet of fabric from threads if you don't interlace them? Well, the answer lies in a whole other category of textiles that are all around us, usually hidden in plain sight. These are called non-woven fabrics. And instead of that neat, orderly grid of a weave, a non-woven is more like a chaotic web of fibers that are all tangled and bonded together. A good way to think of it is kind of like making paper, but you're using textile fibers instead of wood pulp. One of the oldest ways to do this is called felting. The process is pretty straightforward, actually. First, you blend your raw fibers together. Then, a machine with these big combs, called a carder, aligns them into a fine web. You layer a few of these webs up, and then, here's the magic, you add heat, moisture, and pressure. This forces all the tiny scales on the fibers to interlock, binding them all together into one strong sheet of fabric. So why does this matter? Because this technology is absolutely critical to our daily lives. That filter layer in a surgical mask? That's a non-woven fabric. Same goes for disposable hospital gowns, wet wipes, industrial filters, and even the simple tea bag you might have used this morning. They're truly the unsung heroes of the fabric world. Okay, so whether a fabric is woven or non-woven, it doesn't just come off the machine ready to wear. No way. It's in a raw state called gray cloth. To get from there to the finished product, it has to go through a whole series of intense and sometimes pretty surprising finishing processes. And one of the most dramatic steps is a process called singeing. Now, to get a perfectly smooth surface, the raw fabric is literally passed through a wall of open flames at high speed. It's just wild. This process burns off all the tiny fuzzy fibers that are sticking out from the surface, but it's so fast it doesn't damage the cloth itself. It's one of the first steps to get the fabric ready for its biggest transformation: adding color. Now, the chemistry of dyeing is really complex, but the whole process can be broken down into 4 key stages. First, the dye gets dissolved in a liquid bath. Then you put the fabric in, and the dye particles start to gather on the surface. After that, heat and other chemicals help that dye penetrate deep down inside the fibers. And finally, a fixation step locks the color in so it doesn't just wash out. But all of these finishing processes, they come at a cost. All that heating and washing and dyeing requires just immense amounts of water and energy. It actually makes the textile industry one of the most resource-intensive manufacturing sectors on the entire planet. And just to get a sense of the scale of the problem, take a look at the data for just one part of the process: spinning raw cotton into yarn. To get our final product, we start with 950 kilograms of material. By the time we're done, over 126 kilograms of that has just become waste. That's a huge loss before the fabric is even woven, let alone dyed or finished. But the good news is, innovation isn't just about speed anymore. It's also about sustainability. Companies are pioneering some amazing new methods to reduce this impact. For example, Levi's developed a program called Waterless, and it uses ozone gas technology instead of traditional water and bleach baths to finish their jeans. The result? It saves an average of 12 liters of water per pair. So when you really step back and look at it, from the ancient binary logic of the handloom to fabrics made without any weaving at all, and from finishing with fire to finishing with ozone gas, the story of fabric is just one of constant reinvention. We've pushed for speed, for strength, for color. So I guess the real question is, what's the next big challenge? What should we be engineering our fabrics to do tomorrow?